Welcome to Prince Expository YouTube channel. In this video, we will learn about uniform velocity follower motion with the combination of radial cam and knife edge follower. In the previous video, we have seen how to draw the displacement diagram and how to draw the cam profile when the axis of the follower passes through the axis of the cam. Now in this video, once again, we will learn how to draw displacement diagram and how this displacement diagram will be helpful to draw the cam profile, considering now the second case. The second case is the axis of the follower is offset by 20 mm from the axis of the camshaft. Now, the first step in this problem is you have to identify the stroke of the follower is 40 mm. Now, the stroke of the follower 40 mm is drawn vertically upwards. So, because it is drawn vertically upwards, it is denoted with the letter Y, representing Y-axis direction. Now, we need to draw X-axis line. Why we are drawing? Because the displacement diagram is defined as the diagram that is drawn by taking angles of cam rotation on x-axis and follower displacement on y-axis. Now here in the first video we have learned about how to draw this displacement diagram. Here there is no difference in the previous case A and case B. Displacement diagram for both the cases is the same. Now, once again, we will recollect what we have learned in the previous video. You see, the 360 degrees of cam rotation is divided into 4 stages. One is outstroke, dwell, return stroke, and dwell. And some of the cam rotation angles were given for each and every stroke. Now these angles, we have to convert them into centimeters. How we will convert? In the sense, we will go for taking a standard scale. What is that standard scale? Let us say 10 degrees is equal to 1 centimeter. Keeping that as a standard reference scale, we need to convert 60 degrees, 30 degrees, and of course 210 degrees into centimeters. Now after that, we have got all the dimensions in the form of centimeters for showing outstroke, dwell, return stroke, dwell. Now first of all we will look at this outstroke 60 degrees. So as we have considered a scale, 10 degrees is equal to 1 centimeter, 60 degrees is equal to 6 centimeter. So then we have indicated outstroke, followed by dwell 30 degrees, return stroke 60 degrees, and remaining dwell 210 degrees. Now the outstroke and return stroke are prominent divisions because we are concentrating mostly on the outstroke and return stroke. The reason being, in the question it was mentioned, the follower moves with uniform velocity during both the outstroke and return strokes. That is the reason we have to divide this outstroke into n number of equal even parts. So preferably 4 or 6. So in this video, I'm just considering 6 divisions of outstroke. And again, return stroke is also divided into 6 divisions. So then we need to give the numbering of the divisions. You see 6 divisions of the outstroke and 6 divisions for the return stroke. Now, because it was given in the question, the follower moves with uniform velocity. Now, we are supposed to draw a diagonal line that is intersecting all the divisions and then being in contact with the starting point of the dwell. That is the line. And then after dwell, why are we just drawing this inclined line? In the sense, the follower, when it is starting from the cam rotation 0 degrees, will maintain a constant velocity and reaches up to the maximum height with uniform velocity. And then the follower doesn't have any displacement. That's the reason up to 30 degrees it will be dwell. And again, the follower returns back its original position and maintaining constant or uniform velocity. And then for the remaining 210 degrees, the follower will not have any displacement. So this is how we will be drawing displacement diagram, and then indicate the intersecting point of the divisions of this pink line or during outstroke as well as the return stroke. Now in this way we have to draw displacement diagram. Now the displacement diagram is ready for drawing the cam profile for B bit that is given in the question. What is B bit? The axis of the follower is offset by 20 mm from the axis of the camshaft. Now let us quickly look into how to draw the cam profile for the B bit. In the question given, base circle radius is 50 mm. Then draw the base circle of 50 mm radius with OS center. And then there is another information that is given in the question, that is nothing but the axis of the follower is offset by 20 mm. So for that we need to draw an offset circle of 20 mm. So this is offset circle of 20 mm with O as center. Now keeping this offset circle in mind, we need to locate the follower exactly touching the side of the, or touching uh, the side of the offset circle. Now this is the location of the knife edge follower. So that means this offset circle helps us to locate where is the contact point of the knife edge follower on the base circle. Now as the knife edge follower is in contact with the base circle, we will represent it as 0 A. Now the next step is we need to join the center of the base circle. Of course, this is also the center of the offset circle to the point where the knife edge is in contact with the base circle. That means this is the standard line. From here onwards, we need to measure the degrees that were given in remaining all the strokes. Now the next thing is outstroke. Outstroke. We are indicating 60 degrees outstroke. With OA as the starting position, indicate 60 degrees. Then 30 degrees, because after 60 outstroke, 30 degrees is the dwell. And then with OT as the base, we need to indicate another 60 degrees. So that means 60 degrees outstroke, 30 degrees dwell, 60 degrees return stroke, and the remaining angle is 210 degrees. So this finishes the complete 360 degrees. So this is how we have to divide outstroke, dwell, return stroke, and last one dwell in this way. And now we are supposed to divide this outstroke, which is 60 degrees, into 6 equal divisions. Now, as we have divided into 6 equal divisions, we will indicate numbers starting from 1 and up to 6, as we have seen. And then the next step is we have to draw a line. We have to draw a line passing through point 1, and this line should be the tangent to the offset circle. Once again, I repeat, we have to draw a line that is passing through point 1, and that too this line is tangent to offset circle. Similarly, we have to draw a line passing through point 2, which again is tangent to the offset circle. In the same way, we will draw lines passing through the divisions, and that too all lines should be tangent to offset circle. Now passing through the 4, passing through 5, and finally passing through 6. So this finishes drawing all the tangent lines to this offset circle passing through all the respective points in this outstroke division. Next, you look at this, my dear students, displacement diagram during the outstroke. 0 A is at the same point. Here also you observe 0 A is at the same point. Now from 1 onwards we have some distance. 1B we have some distance. 2C we have some distance. So 1B with 1 as starting point, measure this 1B and cut an arc. Similarly 2C cut an arc. 3D 3D cut an arc, and then 4E cut an arc, 5F 5F cut an arc, yeah, 6G 6G. So this finishes this displacements mentioned in the on this cam profile. Now we will now see how those points will be indicated. Now you can see, my dear students, all the alphabets were indicated. Those are the points where we have considered these distances during the outstroke. Similarly, the way we divided this outstroke, similarly the return stroke 60 degrees also should be divided into six equal divisions. Now yes, we were done from 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and finally 6 dash, 6 divisions. And we have to draw lines passing through this 1 dash, 2 dash, and so on up to 6 dash. That line should be tangent to the offset circle. Now let us see the 1 dash. Okay, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and finally 6 dash. That means you see lines are passing through all these points, but these lines are tangent to the offset circle. And now we will indicate in a similar way, we will indicate here O dash H, 1 dash J. You see here O dash H, 1 dash J, 2 dash K, 3 dash L, 4 dash M, 5 dash N, and 6 dash P are at the same point. Yes, in this way we will indicate numbers. And finally, join all the points from A, B, C, D, E, F. Join all the points here and up to the last point P. Also continue joining this or write the line and stop at A. This gives you the cam profile for the second case, that is when axis of the follower is maintaining some offset of 20 mm with the axis of the cam.